Hi, welcome to Pre-Calculus Mini Lectures. Today's topic is using the Pythagorean Theorem to find several trigonometric ratios in a right triangle. So, very similar to last time, except that we are giving some playtime for other functions like cotangent, secant, cosecant, and so on. Let me just quickly refresh everybody's memory one more time. So, let's call this thing A and say B and C, this one angle B, and remember A squared plus B squared is equal to C squared. In other words, B squared is equal to say C squared minus A squared, and then you can take square roots to get the actual length. We have sine of B. We said we write these things so many times until they become second nature. Cosine B, A over C, tangent B is of course B over A, opposite over hypotenuse. Reciprocal of this called cosecant of B is the ratio of hypotenuse to opposite. Secant of B is a ratio of hypotenuse to adjacent, and cotangent of B is a ratio of adjacent to opposite. So we have three numbers. You can make 6 ratios out of them. 3 of them are primary that you see on your calculator. 3 of them are secondary that you see. Well, you have to get to them yourself. They're not on the calculator. And many sections of mathematics runs on just these two. Because they represent waves for us. So we are learning some particular relationship between them, and here is the first example asking us to figure out various trig functions. So between these three, first of all, without doing anything, what can we find? What is the ratio that is represented here? So this is our angle that would be adjacent, and that would be hypotenuse. So of course what I can get for free almost is this ratio 3/8. And of course we can do reciprocal of this, which is 8 over 3. So secant is hypotenuse to adjacent. For other things we need this side B, and of course I need Pythagorean theorem here that B is square root of what now? 8 squared minus 3 squared. Is that right? If you want to calculate one of the legs, it's going to be difference of the squares of the others. If you want to calculate the hypotenuse, is the sum. So here I have 64 minus 9, and that makes 55. So this is square root of 55. So cosine will be ratio of, well, we have it already here, 3/8. Cotangent is ratio of adjacent to the hypotenuse, so this is going to be 3 over radical 55. Secant, well, we already have secant here, is 8/3. Let's just practice other ones as well. So what if I want sine of theta? Sine would have been ratio of opposite, which is radical 55 to hypotenuse. What if I wanted tangent? Tangent of theta would have been ratio of opposite to adjacent. What if I wanted to calculate cotangent? Cotangent would have been ratio of adjacent to opposite. So that would have been well, we have cotangent here, so I'm repeating myself, so I already have cotangent. So sine, cosine, tangent, and cotangent, secant, and cosecant is the one that I should have been writing here. Cosecant of theta is the ratio of hypotenuse to the opposite. That's reciprocal of sine, so that's 8 over radical 55. Okay, so let's see, similar problem here. I have 8 and 7. Let me just label these things as, say, A and B and C. So what is A? Square root of C squared minus B squared. So 8 squared minus 7 squared. That's going to be radical 15. So this is radical 15. So cosine is the ratio of adjacent to hypotenuse. So in this case it's going to be radical 15 over 8. That is our answer. Secant is reciprocal of this, is C over A, 8 over square root of 15. Cotangent is ratio of adjacent to opposite, so that's going to be radical 15 over 7. How about the other ones? So we have, how about sine? Sine of theta is going to be ratio of opposite over hypotenuse. So that's going to be 7 or 8. So that doesn't need the Pythagorean here. And then what else? Cosecant of theta is hypotenuse to the opposite, so it's a reciprocal of this, 8 over 7. And what is left? We have left tangent. Tangent of theta is a ratio of opposite over adjacent, and that's going to be 7 over square root of 15, which is reciprocal of cotangent, of course, and so on. These are pretty much all the same. So this is let's call again, this is A and B and C. In this case C is obtained by adding these two, 3 squared plus 5 squared, and that is square root of 34. So cotangent, whose cotangent is the ratio of adjacent to opposite, so that's 3/5. And then sine, how about sine is ratio of well, let's write B over C, and that's going to be 5 over radical 34. And cosecant is just the reciprocal of this, which is C over B, and that is radical 34 over 5. What is left? Tangent is the ratio of opposite to adjacent, so that's going to be 5/3. Who else? Cosine of theta is the ratio of adjacent to hypotenuse, so it's going to be 3 over radical, what now, 34. And what's the last one? We have sine and cosine, tangent, cotangent, cosecant, and secant. Of course, secant is what is left, is a ratio of C over A, so radical 34 over 3. So we covered all the bases, especially all going back to Pythagorean theorem, two forms of it, and the definition of the 6 trig functions. Remember, cosecant is reciprocal of sine, secant is reciprocal of cosine, cotangent and tangent also reciprocal of each other. And we have, of course, the Pythagorean theorem. If you are calculating hypotenuse, calculating one of the legs, for the legs you subtract, for the hypotenuse you, of course, add. So that was simple enough. Let's move on to more exciting stuff coming up later on. Until next, good luck and God bless.